Hello everyone, and welcome back to our show, Multimed Cosmetic Education. I'm Margarita, and this is Iman. Today we're going to talk about a type of emulsion called a lamellar gel. Iman and I have been hearing about it for years, about how it's superior to the traditional sort of emulsion, and we decided to investigate why.
Exactly, and in particular, we've heard that the lamellar gel helps with the delivery of actives. So before we go further into the lamellar gel network, let's look at the structure of the skin and in particular the epidermis.
To make a long story short, the epidermis is composed of several layers, or strata, and cells called keratinocytes start off in the basal layer. It is important to know that the cells that start off in the basal layer keep changing physically and biochemically and move up through the layers to the spiny layer, then the granular layer, next the clear layer, which not all skin has, and finally the stratum corneum.
But wait, Margarita, you forgot one final layer that occurs after the stratum corneum cells slough off. It's called the stratum dustium, like the one all over your apartment.
Anyway, I chose to use a colored image from Grey's Anatomy here for a retro look, but this barely scratches the surface, no pun intended, of the biggest organ in the body that protects us from environmental stress. Each step of this cycle is fascinating, and today we'll briefly touch upon the stratum corneum. Let's see if we can answer the question of why humans don't dissolve in water.
The stratum corneum is frequently referred to as having a brick and mortar structure. In this analogy, the corneocytes, which are dead cells with no nucleus, represent the bricks. And between them is the mortar or lipids. The corneocytes are connected to each other by desmosomes and covalently bound to components of the lipid layer. So this is a very tough barrier.
So how do things penetrate the stratum corneum?
Well, that would depend on the size and the polarity of the molecules. Margarita, do you have a piece of paper?
No, but I do have this big red foam stuff.
Why?
I was in the laundry room the other day and I found it and I thought it could come in handy.
How does a piece of foam that looks like child-proof flooring come in handy?
Well, we're going to use it to demonstrate skin penetration today. That's not what I thought when I first picked it up. For example, let's say this object is a protein. It's hydrophilic, so it'd have to go in through the pores of the corneocytes, the cells, and it's obviously too big.
Okay, fine. Let's imagine this is petrolatum and it's hydrophobic. It would have to penetrate through the intercellular lipids and it's also too big.
And then finally, let's say that these small objects, the shell and the spool of thread, are molecules, small molecules, niacinamide and retinol, for example, and they are small enough to pass through into the cells. The delivery also matters. The emulsion can deliver the active to the skin in a controlled manner, but penetration depends on emulsifiers, emollients, humectants, concentration, and of course the condition of the skin.
Well, now let's take a look at how lamellar gel networks helped with penetration of actives.
Let's take a look at the lipids in the intercellular space of the stratum corneum. This includes ceramides, cholesterol, and free fatty acids in a 1:1:1 ratio. They pack in bilayers more or less like this.
Lamellar gel ingredients have ingredients that are similar. They're always blends of several of these compounds, which pack into structures similar to the stratum corneum layers. It makes for a good story to say that mimicking this structure using cosmetic ingredients will aid skin penetration. But is it true? In general, yes. Here's an example of a study that found better skin penetration with lamellar emulsions.
This was an experiment that compared the skin penetration of hydroquinone, a skin whitening substance, in lamellar and non-lamellar emulsions. Phosmosomes and hydrosomes are lamellar emulsions, while oleosomes in the system were not. They also tested a regular oil and water emulsion, but it's not shown here because these values are relative to it. That is, they're divided by it. The constant alpha is a measure of how well substances partition between two phases. Higher alpha means higher partitioning. Thus, you can see that the lamellar emulsion, hydrosome, and plasmosome did show better partitioning of the active material across the skin membrane.
Just a bit of background on the experiment. They used a glass device called a Franz diffusion cell. The emulsions were put in here. The membrane was clamped in between. And the amount of active material that crossed over was measured by taking samples from this reservoir. In this experiment, they used 50% water and 50% ethanol in the reservoir, which raises questions of the transferability of the data to real human, in vivo systems. Most people's bloodstreams are not composed of 50% alcohol, except perhaps a few of my great-granduncles on the crazy side of the family.
I think lamellar phases are really cool, and I wish we had a microscope because lamellar gels are liquid crystals, meaning they're rod-like molecules with some form of long-range order. What you see under a microscope is a phenomenon called biorefringence. You know how polarized sunglasses block out certain orientations or polarizations of light? Liquid crystals do something similar in that different orientations of light are refracted differently. So you end up with rainbow-like crystals. That's because solids and liquid crystals have anisotropy, the property of obtaining different values based on direction.
Margarita, what the hell are you doing?
I was trying to fix the ring lamp while you were making up love poems about liquid crystals.
How did you get that over your head? Anyway, while you get that off your head, let's make a final few points. So hopefully, today we've convinced you that lamellar gel emulsions are a desirable technology in products. And it's not though from an ingredients list, you will not be able to tell whether it contains this technology or not. And it's not a marketing claim because most consumers don't know about it. So today we won't be able to direct you towards specific products that do contain the lamellar gel emulsion.
And while we formulated 3 creams over the course of these videos, and the one using lamellar gel technology felt more moisturizing, we changed several elements of the formula. So it's like comparing apples and oranges.
That's it for today. And Margarita, what are you going to be doing with this piece of foam? It's not even big enough to be a yoga mat.